You know, we're letting AI into our lives to do all these incredible things, right? Writing our emails, generating code. We're really starting to trust it. But what if the very foundation we're building this amazing future on has some hidden cracks? What if the tools we're leaning on so heavily aren't nearly as safe as we think they are? Let's dig in and take a closer look. Think about it. Just a couple of years ago, chatting with an AI felt like you were in a sealed room with a super smart brain. You know, what happened in that chat stayed in that chat. But that's not how it works anymore. Not at all. Today's AI agents, they're out in the wild. They're connected to the internet, they're performing actions, pulling down data in ways you might not even realize. So, how are they doing all this? Well, it's through something called an MCP server. Now, you can think of this as the all-important bridge that connects the AI's brain to the entire outside world of data and tools. It's the thing that lets your chatbot go out and fetch a web page for you, or analyze a file you've uploaded. And, as we're about to see, this bridge is becoming a huge target for attackers. So let's kick things off by looking at a flaw that was found in a tool from one of the biggest names in tech you can think of, Microsoft. And it really shows just how easily that sense of trust can be exploited.
Okay, so this is Microsoft's MarkItDown server, and this thing is popular. I mean, it has over 85,000 stars on GitHub, which is a lot. Its job sounds super simple. You give it a file, it converts it into Markdown so an AI can read it. That's it. Seems totally harmless, right?
Well, that right there, that's where the problem starts. What happens when a tool is designed to be so helpful, so trusting, that it just doesn't ask any questions?
This leads us to a really nasty vulnerability called SSRF, or Server-Side Request Forgery. What's so wild about this is how simple the idea is. You're basically tricking a server into becoming your personal inside agent. You get it to make requests to internal, protected networks that you could never, ever get to on your own. So check this out. Here's how the attack actually works. First, a normal user tells the tool, hey, go fetch this file for me. And the server, being super helpful, goes and gets it, no problem. But then an attacker comes along and gives it a special URL, one that points not to a public file, but to a secret internal company server. And because this tool is way too trusting, it just follows orders. It goes right in, fetches sensitive data, we're talking access keys, private tokens, and just hands them right over to the attacker. It's literally like telling a butler to grab a top secret document from a locked safe, and he just does it. No questions asked.
So when researchers pointed this out, Microsoft's official response was basically, this doesn't create significant risk because it's outside normal usage patterns. But Harold Bune, the researcher who found it, had this perfect comeback. He said, people are going to take available software and they're going to use it as they see fit. What he's really saying is, it's on the developers to build in the proper safeguards, because you can't just expect people to use things normal.
Okay, so that was Microsoft. Now let's see how this problem can get way, way more complex. Because this isn't just about one single flawed tool. Our next case involves Anthropic. Yeah, the very same company that actually created the MCP standard in the first place.
Researchers at a firm called Cyata found 3 different vulnerabilities in Anthropic's official MCP server. Now, looking at them one by one, they seemed kind of minor. You had a way to get around path validation, the ability to create new folders, and a read-only command that could be tricked into overwriting a file. On their own, each one seemed pretty manageable.
But, and this is the scary part, the real danger wasn't in any one of those little flaws. The absolute genius of the attack was realizing that these small, manageable issues could be chained together, like dominoes, to create something way more powerful and way more dangerous.
And this is where it just gets brilliant. First, the attacker tricks the AI into reading a malicious file. This file uses that first little bug to secretly create a new code folder. Then, using a totally normal-looking command, the attacker plants a booby-trapped config file right inside that new folder. Now this trap is set to go off the instant any new text file is added. So for the final move, the AI is told to do something super innocent. Just add a text file. Boom! That springs the trap, runs the attacker's hidden code, and it's game over. A complete system takeover. Shahar Tal, the CEO of Cyata, just summed it up perfectly. He said, on its own, each MCP server was relatively safe. But when combined, the cross-interaction is what broke our assumptions. And that, right there, points to a terrifying new reality. In this super-connected AI world, even things that are safe by themselves can become toxic when they start interacting with each other.
So we've got a major flaw in a Microsoft tool, and this wild chain reaction exploit in the official tool from Anthropic. But how big is this problem really?
Are these just one-offs?
The answer is pretty alarming, 36.7%.
So what does that number even mean? It means that when researchers scanned over 7,000 active MCP servers out there on the web, they found that more than a third of them might have the exact same server-side request forgery vulnerability that we saw in the Microsoft tool. This isn't just a couple of isolated incidents. It's a systemic, massive, widespread risk.
And that brings us to this absolute knockout of a quote, again from Shah Hartal. If Anthropic gets it wrong in their official MCP reference implementation for what good should look like, then everyone can get it wrong. I mean, that's the whole ballgame right there. If the company that literally wrote the rulebook on how to do this securely can't even get it right, what hope does anybody else have?
So after going through all of this, what does it really mean for the AI-powered future we're all so excited about building? Okay, let's just quickly recap the big takeaways here. First, these MCP servers are a brand new and dangerously underestimated way for attackers to get in. Second, this mad dash to get AI products to market has meant that real security has been left in the dust. Third, we've seen that even the biggest names out there, like Microsoft and Anthropic, are shipping seriously flawed tools. And maybe most important of all, we now know that in this new interconnected world, even tiny bugs can combine to create these devastating chain reaction exploits.
And all of that leaves us with one final, and I think pretty critical question. As we race full speed ahead to build our entire future on top of this incredible new technology, are we even taking a second to check if the foundations can actually hold the weight?